Welcome for today's session, Introduction about Hill Cipher and C implementation. The Hill Cipher is a polygraphic substitution cipher developed by Lester F. Hill in 1929. It encrypts data by using linear algebra principles, making it one of the easiest ciphers based on mathematics. This cipher encrypts blocks of text by using matrix multiplication with a predefined key matrix, which makes it stronger than many simple substitution ciphers. The Hill cipher works by encrypting text in blocks, typically 2 or 3 letters at a time, rather than encrypting individual letters. This makes it a polygraphic cipher which is resistant to letter frequency analysis. This encryption process involves converting letters to numerical values, then multiplying these numbers by a key matrix, followed by converting the result back to letters. These are the formula for encryptions and decryption. The encryption formula for the Hill cipher is C is equal to E of K comma P is equal to P into K mod 26, where P is the plain text and K is the key matrix, C is the resulting cipher text vector. For decryption, we use the inverse of the key matrix represented as P is equal to D of K comma C, which is equal to C into K inverse mod 26, which is equal to P into K inverse mod 26. It is crucial to use a key matrix that has an inverse mod 26, otherwise decryption becomes impossible. Let's go through the steps involved in implementing the Hill cipher in C. Here we are taking C1, C2, C3 as a cipher text blocks and P1, P2, P3 as a plain text blocks, and this is the key matrix we are using K11, 12, 13, 21, 22, 23, 31, 32, 23. Like this 3 by 3 key matrix we are taking and we are doing with multiplying with mod 26. Because the alphabets we are taking 0 to 25, so we are multiplying with mod 25 for encryption. For C1, we are taking P1 into K11 plus P2 K21 plus P3 K31 mod 26. In the same vice versa, C2 and C3 also we are taking according to their plain text with the key matrix, and P2 with the key matrix and the P3 with the key matrix, and we are multiplying with the mod 26. These are the sum of the texts. These are the sum of the steps in C program implementation. Let's go the steps which are involved in implementing the Hill cipher in C. First, define the key matrix, typically a 2 by 2 or 3 by 3 matrix for encrypting each text box. Next, we take a plain text input, convert it into numerical values, and split it into blocks. We then perform the matrix multiplication for each block to encrypt. For decryption, we calculate the inverse of the key matrix and apply to it the cipher text box to retrieve the plain text. Modulo operation we are using to take modulo 26 for each resulting element. To display the result, we will convert integers back to letters. Let us discuss an example here. We will take the question, encrypt, pay more money using Hill cipher with the key. So here we are taking the alphabet numbers regarding A is 0, B is 1, C is 3, A, B, C, 0, 1, 2, 3, like this we are taking. Let us suppose we are taking A value is 0, E value is 4. Like this we are taking each one of the alphabet to their corresponding number. The key we are taking 3 by 3 matrix, and we are taking the plain text in the form of P1, P2, P3, P4. So P1 is PAY, P2 is MOR, P3 is EMO, P4 is NEY. And these are the key matrix and their corresponding letters. So the corresponding letters we are taking here. P value 15, A value 0, Y 24, M 12, like this we are taking. Let us take here the first P1 term. The P1 term is PAY. So let us take C1, C2, C3 is equal to P1, P2, P3. So the P1 value, the P to their corresponding number is 15, A to their corresponding number is 0, Y to their corresponding number is 24. This is the key matrix they are given. 17, 17, 5, 21, 18, 21, 2, 2, 9 into mod 26. Then we are multiplying with the row with the column number. So 15 into 17 plus 0 into 21 plus 24 into 2. Like this, we are taking the second row, first row and second column. 15 into 17 plus 0 into 18 plus 24 into 2. And we are taking the row with column here, third column. 15 into 5 plus 0 into 21 plus 24 into 19. So we are taking like this into mod 26. So we are getting the values 303, 303, 531, mod 26. So after applying the mod operation, we are getting the numbers 17, 17, 11. So according to the numbers, to their corresponding letters, we are getting R, or L. So in the same manner, this is where we are taking the plain text PAY. Okay, let us take one more value, um, one more encryption term P2, MOR. So we are taking PAY now, then MOR, then EMO, then NEY. Like this, we are dividing our plain text into blocks. Let us discuss about the MOR. We are taking the M value 12, O value 14, R value 17 with their alphabets value and their corresponding numbers with this key matrix. So in the same manner, if you are multiplying row with the column, we are getting the values 12, 22, 1 after doing the mod operation. Then we are getting the corresponding numbers to their corresponding letters. 12 value is M, 22 value is 11, 22 value is W, 1 is B. So like this, we will take one more value here, MOR. So if you apply K, MOR, MON, MOR, EMO, NEY, we are getting the values RRL, MWB, KAS, PDH. Like this, we will convert the plain text in the form of ciphertext. This is nothing but the conversion of plain text to the ciphertext with the help of a key matrix. Let us decrypt the same one here. We are taking the reverse of the encryption is nothing but the decryption here. The decryption requires K inverse, that is the inverse of the matrix K. To find out the inverse of the matrix K, so we are applying the formula 1 by determinant K into adjoint K. So to find K, we are using the adjoint K here. Let us take the determinant, let us find out the determinant and adjoint here. For the determinant, we are taking det, the key matrix, into mod 26. Let us apply this one. Here we are taking the first row and first column. We are eliminating 17 into 17 into 18 into 9 minus 2 into 21. Next, we are finding out minus 17 into 19 into 21 minus 2 into 21. Okay. Then plus 5 is equal to, so we are applying the row and columns here, we are eliminating. In the same manner, we are applying here 5, we are eliminating 5 into 21 into 2 minus 18 into 2. Like this, every time we are finding out the determinant of mod 26. After doing the calculations, we are getting minus 3 mod 26, which is nothing but a 23. So this is the determinant of K. So let us find out the adjoint of K. To find out the adjoint of K, we are adding the two rows at the end of this matrix. So let us take the two rows here, 17, 21, 2, 17, 18, 2. These two we are adding at the end of this matrix. Then we are taking the two rows at the end of this matrix. So these are the two rows here we are taking, which we are adding to the matrix. So this is the adjoint K matrix we are considering. So let us eliminate the first row and first column. Then whatever we are getting, it is nothing but the adjoint element of the matrix. Let us find out the column wise and row wise operations here. 18 into 19 minus 2 into 21. So here we are taking 2 into 5 minus 17 into 19, 17 into 21 minus 8 into 5. Like this, we can do the multiplication to find out the adjoint of the matrix. Then we are getting the values like this. So after performing the mod operation, we are getting the values 14, 25, 7, 7, 1, 8, 6, 0, 1. Like this, we can perform the mod operation. So now we are finding the determinant k value and adjoint k value. The determinant k value is 23 and adjoint k value is 14, 25, 7, 7, 1, 8, 6, 0, 1. This is the adjoint k. So to find out the K inverse of the matrix, we will apply the formula here. The formula is 1 by det K into adjoint K. So let us find out this 1 by 23 is nothing but the 23 inverse into matrix of mod 26. Let us find out the value for this 23 inverse. The 23 inverse is nothing but by calculating the formulas here, we are getting 23 inverse is nothing but the 17. So let us multiply with 17 into 4, 17 into 7, 17 into 6. The same manner, we are multiplying with each row and each column of this matrix. We are getting the values like this. When we are applying the mod operation, we are getting the inverse of the matrix K. This is to find out the K inverse of the matrix. Let us apply how to decrypt the ciphertext and convert it into the plain text. Let us take that one question here. Decrypt RRR, MWB, KAS, PDH using hint cipher with the key. Okay, so let us take the matrix here. The matrix and their corresponding values we are written here. The corresponding values for this one is RRL, MWB, KSS, PDH, and their corresponding numbers according to the alphabets. A value is 0, B value C. Like this, we will take all the A to Z alphabets and their corresponding numbers here. Let us apply the formula to decrypt the ciphertext. So to find out the plain text, we are using P is equal to C into K inverse mod 26. Let us apply the formula here for this one. First, we are taking RRL. So the RRL value, the corresponding numbers for the R is 17, 17, and 14. With the key matrix we are applying, we will multiply with the mod 26. Then after doing multiplication, then we are getting the cipher, we are getting the plain text here for RRL is equal to the PA by. In the same manner, we will find out the remaining terms MWB, KAS, KDH. After converting this everything, we are getting the values pay more money. So this is the conversion of plain text to the ciphertext and ciphertext to the plain text. Let's review the advantages and disadvantages of the Hill cipher. One of its strengths is the use of matrix multiplication, which makes it more secure against frequency losses and improves encryption strength. However, there are the challenges. The Hill cipher requires the use of invertible matrices, which limits the choice of key matrices. It's also vulnerable to attacks if multiple plaintext ciphertext pairs are known. Overall, it is an effective cipher for secure block encryption, but can be complex to implement and decrypt without the correct technique. So this is about the advantages and disadvantages of Hill cipher. So after completion of the session, the student will be able to learn how to understand the basic principle of Hill cipher, understand the encryption and decryption process in the Hill cipher. With this, we will conclude our session. Let's implement the C program for Hill cipher.